Assalamu alaikum students. Today our topic is current electricity. SLO of this topic is draw and interpret the IV characteristic graph for a metallic conductor, a filament lamp and a thermistor. Second SLO is describe electric power. Before doing these two SLOs, we are doing ohmic and non-ohmic conductors. What are ohmic conductors? Materials which obey Ohm's law are called ohmic conductors. For example, all metallic conductors. Non-ohmic conductor. Materials which do not obey Ohm's law is called non-ohmic conductors. Obey Ohm's law means V is directly proportional to I, and do not obey Ohm's law means V is not directly proportional to I. For example, in non-ohmic conductor, ionic solution, gases and semiconductors are non-ohmic conductors. You see the example of the conductor, this cable wire, and non-ohmic conductor, different types of diodes, and these are the examples of non-ohmic conductors. What is an IV graph? I stands for current, V stands for voltage. What is an IV graph? An IV curve, short for current voltage characteristic curve, is a graphical representation of the relationship between the voltage applied across an electrical device and the current flowing through it. It is one of the most common method of determining how an electrical device functions in a circuit. What is the difference between IV and VI graph? Both the IV and VI graph shows the relation between potential V and current I. In VI graph, we take potential at y-axis and current at x-axis. In IV graph, current is at y-axis and potential is at x-axis. The reciprocal of the slope of IV graph shows the resistance. The IV characteristics for metallic conductors, a filament lamp and a thermistor. Metallic conductor. For the case of pure metallic conductors, the ratio of V upon I is equals to R resistance remains constant provided physical conditions such as temperature remain constant. That means for a metallic conductor, if we divide V by I, the answer is a constant and that constant is known as R. The graph of metallic conductor is a straight line, which shows that V is directly proportional to I. The graph shows the resistor is obeying Ohm's law. The straight line tells us the current is proportional to the potential difference across the resistor. Here we take V on x-axis and I on y-axis, and V is directly proportional to I, so graph shows a straight line. IV characteristic graph of filament lamp. You see, filament lamp means this common bulb. Here filament is used. The graph, IV graph of this filament lamp is a curve. It is not a straight line, which shows that V is increases and I is also increases but not proportionally. The resistance of a filament lamp increases as the temperature of the filament increases. Reversing the voltage, negative values on the graph reverses the direction of the electric current but does not change the shape of the curve. You see negative value. The direction is changed but the shape of the graph is same. The lamp does not obey Ohm's law because the graph is not a straight line. You see the curve? V is increasing. I is also increasing but not proportionally. Thermistor. IV characteristic graph of thermistor, you see, it is also a curve, not a straight line. We do not obey the Ohm's law. V is increasing. and I is also increasing but not proportionally. The graph for a thermistor is not a straight line and therefore does not obey Ohm's law. The plot is actually the reverse of that of the lamp. In the previous, you see the graph of the lamp, the curve is like this in this direction, and here the curve is in the above direction. The thermistor is a semiconductor and conduct more electricity when heated. This is because as the temperature increases, the thermistor makes available more free electrons to carry the current. Therefore, as the current increases, the thermistor gets hotter, releasing more electrons, resulting in a reduction in resistance. Alright, next topic is electric power. The amount of energy supplied by current in unit time is known as electric power. Electric power is equals to electrical energy upon time, or mathematically P is equals to W upon T, where W is the electrical energy and given by W is equals to QV. We also have done W is equals to QV. Put this value of W in this equation, P is equals to QV upon T. This equation becomes P is equals to QV upon T. QV upon T. But by the help of the current definition, we know that I is equals to Q upon T. So Q upon T, instead of Q upon T, we will put I. So this equation becomes P is equals to IV or VI. Substitute P is equals to IV or VI. But by Ohm's law, we also know that V is equals to IR. So put the value of V in this equation, it becomes P is equals to I multiplied by R, so I square R. This is the final equation of the electric power. P is equals to I square R. This is the picture of the electric power. The SI unit of electric power is watt, which is equals to 1 joule per second, because the unit is W upon T, and W is the unit of W is joules, and the unit of T is second. So the unit of the electric power is joules per second, or 1 joules per second. The symbol of watt is W. Thank you guys. I hope you can understand electric power and IV graph of metallic, metallic conductor, filament lang and thermistor. Thank you.